Hi students, welcome to my lectures on mechanical unit operations. Today we are going to discuss about critical speed of a ball mill. What this critical speed is, okay, in the ball mill steel balls will be kept and the drum will be rotated, okay. While the drum is getting rotated, the steel balls which are inside the drum is going to get lifted and dropped. Because of this dropping action, whatever the particles are there in the drum will getting crushed, okay. This is the ball mill. Inside there will be as many number of balls we can keep according to the requirement and the capacity of the mill. And today the objective is to find out at what speed I have to rotate the drum, okay, because ultimately the feed which are there inside the drum will be crushed by the particles, right? Particles, if there is a feed on this drum, the particle will be lifted and dropped. Because of this impact force, the particles will be crushed down. And you must be worried, okay, the particles will be crushed, and what is the speed I have to operate the centrifugal force, okay, what is the speed I have to rotate it? See, there are two forces that act inside the ball mill. One is because of the weight of the ball, the gravity will act the downwards, and second, the centrifugal force which acts on the periphery, okay. Imagine if I rotate imagine this is the ball inside the drum which is getting rotated, okay. Once I am trying to rotate, there are two forces acting on this particular ball. One is the centrifugal force which acts away, and the gravity force which acts at the downward. At any point of location, the centrifugal force and the gravity force acts on any particular ball which is getting rotated, okay. If I rotate the mill at a lower speeds, okay, imagine I am rotating the mill at lower speeds, the ball is getting fall down, okay. More is the centrifugal force, more is the height it is going to go, okay. More is the centrifugal force, more is the height it is going to get and getting dropped. What happens if I rotate this particular drum at very high speeds? See, there is no dropping of the ball, the ball is getting rotated along with the drum. In such cases, the ball won't fall down, it just rotates just like a satellite is revolving around the earth. When the ball will not get fall down, the material will not be crushed, okay. That means there is some speed which I have to operate a mill. What is the rotations per second, rotations per minute the drum has to rotate? This is a 2 revolutions per minute or 3 revolutions per minute I have to rotate, because if I go for higher RPMs, that means more is the rotations, then ball will never fall down. This is the concept of the critical speed, the speed at which the mill cannot go beyond, okay. That is called the critical speed of a ball mill. So let us go and do the derivation to find out an expression later on we are going to calculate, okay, with a small example. Okay, let us go. This is the drum I am talking about, okay. This is the drum, okay. If you watch my earlier videos, I have shown the ball mill. The ball mill, inside the steel balls will be kept along with the feed material, and the drum start rotating. So this is the drum, this is the feed material inside the drum, and this is the steel ball I am talking about. It will get lifted at a certain height and it will be dropped because of this rotating action of the drum, okay. The drum will get rotated, the ball will be lifted and at a certain height and it will be dropped, okay. And what height it should lift, okay, it depends on the centrifugal force that is acting, because the more is the speed of the drum, more height it is going to get achieved, okay. That is what this is. These are the feed particles, and this is the ball at a certain location, and r is the radius of the drum, and the small r is the radius of the ball, and capital R minus small r is this particular distance, because center of gravity of the particular ball, because any center of gravity of any particular sphere balls lies at the center. So the distance from drum center to the ball center is nothing but r minus r. So this is the schematic, and this is the presently the angle made by the ball is theta. If this is theta, this is also theta, because these both are parallel lines. Okay, if this theta is the angle and this is also the same angle, this is the starting point of the derivation. How it goes? We have to balance the centrifugal force and the gravity force to find out the critical speed. Why? Because the ball, the maximum distance the ball can go is this. Okay, if you provide the more centrifugal force, the ball will not fall. If the ball will not fall onto the feed particles, the material will not be crushed. So that is why agenda is to find out at this particular, for me to lift the ball to this particular height, what is the RPM. So that is the maximum RPM I can go, that is the critical speed I can go. So let's go with the derivation. Force balance. If I take the ball here, I take the two forces, one is the centrifugal force and one is the gravity force. I always have to take the balance along this particular line, because along this line the centrifugal force is acting from the center to away from the center. So along this line I have to act what is the gravity along this line and what is the centrifugal force along this line. mg, okay, always acts the downward. Okay, this is the gravity force mg. I can divide this gravity force into two components. One is horizontal component, one is vertical component. Because if you see, these are the two perpendicular directions. If this is the actual force, the force along this line which is making an angle theta is called mg cos theta. The rest one, this force is mg sin theta. This is called resolution of the forces. Okay, you can resolve any forces into parallel and perpendicular components. Okay, two. And if this is the actual force, this is the mg cos theta because it is making an angle theta, and the remaining force which is acting along this is called mg sin theta. So I have to, now what I told you, I have to draw a balance between along this particular line. Okay, at any position along this particular line, gravity force is equal to centrifugal force. Okay, this is the maximum force, because at a specific RPM the ball, the maximum height it is getting lifted when these forces are getting balanced. Okay, and centrifugal force is equal, gravitational force is equal to centrifugal force. Along this line, what is the gravitational force? mg cos theta, and this opposite force is equal to centrifugal force. If you remember, what is the centrifugal? mv square by r. Okay, mv square by capital R minus small r. Why capital R minus small r? I has already discussed. The center of gravity acts at the ball center. From center to the drum to the center to the ball, the distance is r minus r. So that is why always you have to take r minus r distance. So mg cos theta is equal to mv square by r by r minus r. What is the v? V is the peripheral velocity. How many meters per second the ball is getting, the drum is getting revolved. Okay, v is the peripheral speed. What is m? Mass of the ball. Okay. When you equate these two, the cos theta is equal to v square by r minus r into g. What is v? Peripheral velocity. Peripheral velocity means how many meters per second the ball is getting rotated depends on 2 pi. You know, if one rotation, it is covering the distance of 2 pi r. But here r is r minus r. So at every rotation, the ball, the drum is covering the distance of 2 pi into r minus r, which is why meters per rotation. Always keep it in mind, the units are very important. 2 pi r, that means velocity is equal to, but velocity is meters per second, right? See how I will get meters per second. 2 pi r is equal to meters per rotation, n means the speed of the drum, rotations per minute. Okay, every second how much it is getting rotated, and every rotation how much it is getting covered. Rotation get cancels out, the velocity is in meters per second. Okay, once you put 3 in 1, the cos theta is equal to 4 pi square n square r minus r by z. So from this, at what is at the critical speed? At critical speed means when the ball reaching the top position, that is called the critical speed. Okay, at the critical speed, what is the angle made by this particular line is 0, because as you cover the distance, the angle is getting reduced, and when you reach the vertical stage, the angle will be 0. Okay, at critical speed, theta equal to 0 degree, then in such at that particular location the maximum drum rotation that is going to happen. So that is n equal to nc at that part the rotations at which the maximum that is going to take place, which is called nc. From this I will take out the n on one side, rest on the other side. So n became nc 1 by 2 pi into square root of g by capital R minus small r. The units 1 by 2 pi, the units are 1 per rotation, gravity in meter per second square, r minus r is in meter. So finally you get rotations per second. Okay, this is how the units for the critical speed of the ball mill. Hope what is the critical speed? This is the maximum speed you can go. Okay, beyond that the ball will never fall onto the material, so it will continuously rotate just like a satellite is revolving around the earth. Okay, I hope it is clear. Let us calculate the critical speed of the ball mill with a very small example. Okay students, this is the small example that to finding of critical speed of a ball mill. Okay, what is the maximum speed a drum can rotate? Okay, find the critical speed of a ball mill given radius of the drum 0.5, radius of the ball 0.035 meters, gravity 9.8 meter per second square. What is the critical speed? 1 by 2 pi into square root of g by capital R minus small r, that is 1 by 2 pi into 9.8, 0.5 minus point, always keeps in mind when you take z in terms of meter per second square, capital R and small r should be in meter. Okay, then only you get units gets cancels out, you get rotations per second because g is in meter per second square, right? So you get rotations per second. So by putting up this in formula, you get the critical speed is nothing but 0.73 rotations per second. If you convert the second to minute, that is called 43.85 rotations per minute. But every minute the drum cannot go beyond 48 rotations. If it does, I mean that means you are above the critical speed, the ball will never fall onto the material and material will not be crushed. Okay, I hope you have learned what is the critical speed of the ball mill. So let us meet in the next video. Thank you.